Hello everyone! Today we will be going through the B-tree walkthrough. Alright, so we're going to be focusing on going through the code walkthrough, then coding the B-tree from scratch. I feel like you're not going to learn anything from coding the B-tree from scratch. I feel like you're going to learn more going through the walkthrough. I'm going to explain how this code works. Alright, so on the left side you can see this is our code written in Java, and on the right side these are the values we're going to insert. Alright, and I'll be putting this code on my GitHub, so you guys can study it later. Alright, let's go through the code walkthrough. Let's do it. Alright, so as you can see right over here, let me get my pointer. Alright, this is the B tree, and right here is the class. It's the internal class. This is the node. This is the inner class here, as you can see. And this is the B tree here. This is the constructor we're going to initialize. All right. So let's go down. Let's go into our main function here. All right, let's go to the main function. It's all the way down there. All right, here's our main function. So when we initialize B tree, T will be 2. This is not the order. Again, this is not the in order. T will be 2. The in order is T times 2, which is 4, since T is 2. So this code will be working with an order of 4. Okay. Just let me make that clear. Again, I'll explain why we're doing this. Because in the B tree, in the code, you need extra spaces in the arrays. That's why we're doing this. Again, once we go through the walkthrough, everything will make sense later. All right. So as you can see, in the main function, we initialize the B tree constructor, right? And B tree is 2. So, all right. Once we do that, we initialize the root node. So T is 2, and let's just do it over here. So let's have a little bit more space. Root here is when we initialize the B tree. So when we initialize the node here, once we initialize the node here, we go to our root node, and let's do the initialization of the properties of the node. All right, so what is the key for our node? Our key is, we will have the keys of 3, since 2 times T, which is 2, take away 1. So this will be 2 times 2, so 4 take away 1. This will be 3. Just want to make that clear. So when we have row, so we initialize the keys. The keys are int. So here, the keys are 1. Let's make this a little bit bigger. Yeah, okay, just erase this here. Keys 0, 1, 2, 3. All right, these are the keys. And right here, we have, I know it's supposed to be 0, 1, 2, since the order is m equals 3, and we should have only 3 keys in our array, but we just need this one here, so we put this one, why we do t times 2 is so we could have extra space. We're going to need this extra space right over here later, and you'll see. We need extra space in the array. Alright. Okay. The child's are 4. So 0, 1, 2, 3, 4. Leaf is true. Okay. And n is 0. Okay. So if we go back to our main function, we're going to insert 8. So I put the red marker so we can keep track where we are. Okay. And we're going to go up. Okay. And we're going to go to insert right here. So we insert the key. So 8 is here. All right. We have an R. We create a new node. Do we meet any of these constraints? So R, we copied it, so it would be the same here. 0 is equal to 3. No, so right here is 0 equal to 3, because since we copied it here, the new node, we copied it, and you can see n is 0, so we don't go into this if statement, and then we just go into insert value, right? And in insert value right over here, you can see that, so we could say we bring in the R node in here, and we're bringing 8. Is this a leaf node? It is a leaf node. That is true. All right, so right here, this for loop sorts everything out. So when you insert something into a B tree, it has to be in sorted order. It sorts it out. All right. It puts it in its place. So it would be this would be in its place. So it does it. X take 1. I is 0. Is there any elements? Is k less than any elements there? There's no other elements in here, so by default, so we insert 8 here. Okay. And then n, since R is pointing, since it's pointing to R and R is pointing to root, we say n is here for the root equal to 1, because we add 1. All right. Now we're going to do the same so we insert 8. Now we're going to do the same thing with 9. We're going to go up here. We're going to insert 9. Is 1 equal to 3? 1 is not equal to 3. So we go to insert value here, insert 9. Okay, and then we, right over here, we sort everything out. So we realize that there's the key is greater, the key is greater than most of them. So right here we just insert 9. And then we change n to 2. All right. And then we repeat the process for 10. So we're going to insert 10. All right, is 2 equal to 3? No. So then we bring it here. All right. So we go here, we do the sorting. It's a leaf node. We do sorting and is so x minus 1. So this would be right here. To take away 1 will be 1. We start there. 1 is greater than 0. And then is this greater than the values before it? No. K is not less than the values before it, so we don't have to go through this for loop. All right, and that for loop sorts everything out, and then we just put it here into 2. We put in 10, and then n is equal to 3. All right, this is where the fun happens. All right, so now we want to insert 11. All right. Again, we repeat the same process. R is the root. This is true. Right here. This is true. R is equal to 3. 2 times 3. So we do the key split here. And we also create a new node S. And S is now, S becomes the root. Okay, so now root is pointing to S, right? Again, root is pointing to S. And S is new. So Wait, this is a little bit tricky to explain. So I'm just going to re-explain this right now. S becomes a new node, right? But S is the new root. Now, as you can see here, R is pointing to the old root. So S is the new root. So we create a new node again. All right. So, okay, I'll just explain everything. So right here, S is initialized. We create a new node. In a new node, we have, but this here, when it's initialized, the only difference is usually the new nodes, the leaf is true. Here, in this case, it's false. All right. And then right here, as you look, and then you have n equals 0. All right. And then you have, let's say, the keys here. Keys will be, let's make the keys a little bigger. All right. And then children. So we have okay. And then you can see in the code here that this R becomes child 0. So we're just going to make a quick flip here. Let me just go here, just so here. This here R becomes child 0. So, and root becomes a new node. So let's just show right here. Let's move everything. So let's move everything up here. Hold up. I just want to move this here. Come on. Come on. Let's see if I could just move this here. Oh, crap. Okay. How if I just move this here? All right. Let's see if I could just, yeah. Okay. Sorry about that, guys. Just move this here. S. And then R. Again, probably going to edit this out. And here R. So, all right. and just see if I can. No, I can't shrink it. Silly me. All right. Again, sorry about this. All right, here, S, and we just call this here R. Okay. And if I could just move, see if I can, oops, just see if I can move everything onto the other side smoothly. Okay, and here. Cannot. See? Come on. Just gonna erase this crap here. Okay. Yes. Come on. Here. Our children. And we'll just call it this one here. R. And just this one here. If is true. And n equals 3. Okay. Awesome. And maybe just get this one here. Awesome. So right here you can see we got lost kind of track here. You can see right here, where's the insert? You can see here in the insert we made a switch. Okay. And let's just call this here R. And R is child 0. Let's make this one clear. Child 0. R is child 0. Okay. And then from there we go into the split function. After we do this whole switch, we go into split. All right. And then we're going into split after the switch. Oh, where's split here? All right, split is here. All right. And then from split, so we have, and we'll just call this with S, the head node. Okay. And we're probably going to get another page for split. And then let's take the code from split. All right, so here, let's just take this code from split. Split, 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 split. And I'm going to explain what's happening in split right here. Okay, so I'm going to split. And this kid gets split here. Copy, and then copy, and then hold up. And copy, and then split. Actually, oh wait, we have space here. Actually, I'm just gonna move this code up here. All right, sorry about that, guys. Just gonna move this. Just gonna move this one up here, just way up. Okay, and then from here, see if we can have room down here to explain what's going on in split. And this is so. Okay. So let's focus on split. So as you can see here, in split, this will be R, and the new one right here would be, this would be S. S would be X, and this is 0. Alright, let's maybe change the color up. Alright, so in split, what's happening is we create a new node called, this here is just for split, called Z. Alright, this new node, the leaf is true, and is 1. Alright, and right over here we're going to move the last element from Y. Y is R, the one we're copying, 10. We're going to copy it into Z. So we're going to have their keys. I want to be clear. We are just going to maybe highlight this one. We're going to copy the last element from from Y into Z's key. So here, here, here. So you have 0, 1, 2, and then you have this one here, 3. So we're gonna move. This one would be 10. All right. Y is not the leaf node. It is a leaf node, so we don't have to go through here through this if statement. And then Y becomes 2. So this one here, y. So I'm going to change this one here. This one's pointing to y. Y is r. This one's over here is r. We're going to change that one to 2. Oops, make it white. All right. Then we go, and then where do we go? After that, we don't have no children nodes, so position is 1. So we already had exerted a position in 0, so 0 plus 1 is 1. So now we copy this node Z into our root node, or S, you can say. So this will be here. Let me just, now Z is going to be copied. Okay, silly me. Okay, just going to remove this here, and I'm going to copy this one here, and the position. Okay, I'm going to copy. So let me just put something here. We are right here. We're right here. And Z is going to be copied into S. So just move this. And then I can go, see if I can go up. I can. Okay, and this is going to be this one here. Oh, silly me. This one here is going to be 1, child of 1. Okay, now let's go back into the code. And then this loop here does not apply. So now we take, so from Y, this one here, right over here, which is R, right? We take the middle node and we move it up to S. Okay. So the middle node is 9. So we're going to move this to here. All right. And we are, okay, just want to be clear. We're here right now. Okay, and let's just do 2 take away 1. T is 2, is 1. So this one would be here. R is this one. I just want to be clear. R is Y. So we're just going to take this one here, 9, and move it here. All right. And then here also, just want to be clear, there is an equation here too saying that we should y should be equal to 1. T2 take away 1 is 1, so this one here is 1. All right, And if you go over here, right over, and right over here, X. So we go X is S, just want to be clear, and we increment it by 1. So you say now, say this was now N is equal to 1. All right. And then we go over here, insertion. Let's go to insertion. So we have here 8, 9, 10. So 8, 9, 9, 8. Okay, oh, yeah, when we're doing Z, we're inserting 11. Just want to be clear, when we're inserting 11, we forgot one thing. All right, we're finished the split now, right? So we could now insert, we're inserting 11 before, right? So now we're going to go insert 11 into here. We split it, and now we could insert 11, and it's the same process as before. We'll insert it into the first child. So we do the sorting thing here. Oh, yes, sorry. Yeah. Everything sorts out. 10, and then we put 11 here. All right. Sorry about that. And then right over here, after 11, 7 and 20. So when we're inserting 7, this is what's going to happen. Let's do this. All right. We have 7 right here. We insert 7. We realize that the first X is not S is not a leaf node. So then we go here. We go here, and then, all right, we don't meet us. We don't meet any criteria, so we just go here and we just recursively keep calling until we reach the end of the child nodes, until that child node is null. Okay, and then we do 7. Then we do reach a leaf node. And it's just the same process as before. All right. 7 is now insert value. We recursively called insert value recursively. All right. And now we reach 7 with the leaf node where 7 fits in. All right. And then we just do the shifting thing. All right, all the keys shift down. So here 8, 9, 10, and 7, and this one here. Okay. And this here now becomes 2. Okay, 7, 8, 9, 10. This is why right here we explain that we have an extra space in the array. We always need to, that's why we do t times 2. And then, all right. And where are we right now? Okay. And then after 7, we're going to insert 20. Okay. And then we have 20 right over here. All right. And we just insert, do the same process as before. We go to insert value. All right. And then in insert value, we insert 20. We were inserting from our root node, or you could say S. And then what's happening here is we then go here, we call this recursively until we reach our, call the statement recursively until we reach our root node. All right. And then we just insert 20. We don't need to do any shifting because 20 is greater than 10 and 11. Okay, how am I going to do insert 20 here? Okay, we just put 20 here. All right, and the fun happens is when we do the insertion of 17. So let's do this one real quick. So we go here. We go to insert. (17). It checks if 17 is full. I mean, so if Rn, the root node, is full, it's not full. This is not full because it's equal to 1. So we go in here, and then we go to insert value. Again, R is not a leaf node. All right. So software is so hard to use. Keep going, 17. All right. We go to insert, okay, and we just go to insert value, and then we're right here. We end up right over here. Again, 17 finds its placement, its position. So the position will be 1. We keep calling recursively until we find it, and it realized, oh, 17's child, the child node that is supposed to call 17, that child node is full. Okay, so we do another split. We do a split right here. Okay, we're going to do another split right here for 7. We're going to do another split right here for 17. All right. because we're right over here, and we realize that our child node right here, 17, though we want to insert the leaf node, is full. So what we do now is do the insert, put 17 here, and then so we'll do a split. We'll draw another split. Okay, is it possible if I could do a split here? Okay, insert value here. Okay, and I'll just erase everything here. Maybe get a bigger eraser. So we do the split. So let's go to my notes real quick. So the split here, X, because say this is the root node right here. Position is 1, and the temp where 17 is. So this we'll put here Z, the child node we're trying to change. All right, and right here is we call Z again. Let me see if I can get the split function so I can show you here. Do a trace. Split, 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 split. Here. This is where split is. All right. So you could say here Z is. Oh, we're copying ZZ. Sorry. So we'll just say this is the child node. This is child 1, just to keep things simple, because we're already calling Z. So we'll just say this one's here is child 1. Child 1. Okay. Is child 1 a leaf node from here? Yes, it's a leaf node. So here n equals 1. Sorry, t equals 1. N equals 1. Okay, and we copied and then Z keys here. Z keys. It is, what is Z keys? So we're going to copy the last element of that child node. So last element is 20. So that's going to be copied here. All right. And then, all right. And then we're right over here. And that node we're just called is going to be, so right here, we're going to change this here and to, so n is 1. So when we were doing the insertion, the n was 3. So n is going back here to be 2. Sorry, n will be 2. And then position 1. So here, this is going to be pointing to the child. So this one here is now going to point to child. We're right over here. This one here is going to point to child 2. Actually, let's just quickly see if I can move everything. Okay, just get this code here, here, here. Okay. We don't need to go through the code anymore. Alright, just let me see if I can copy everything here. Fabulous, I could do that. Okay. Let's see if I can get this one here. Sorry. Okay. Just here. Alright, whatever. Just gonna rewrite everything here. So in the code we have a new insertion here. And we'll just call this the new one. So leaf is true and equals 1. And the keys is 20. Okay. Okay. 0, 2. This is child 3. So, and then right here, we're finished. Oh, we're not finished. Let me just see if I can get the code. Okay, where's the code here? I just need to get the code. I need the code. Come on, get the code here. Here. Alright, and then we have to copy the middle position. And then we're right here right now. We have to now copy the middle position here. As you can see, we need to copy this middle position right over here. Right here, we have to copy this middle position. So X, so what was over here, we need to copy over to the root node. Okay, we're going to copy this here, the previous, into the root node. All right. So we're going to copy this here, 11, to the root node. And then you go here. Okay. And then this here is Y, so this gets, so this right here, you're looking, will be put into 1. So reduce this one to here to 1. To 1. All right. And then where are we here? And then X, we're right over here in the code. And then we just add this one here. We add X to 2. We have 2. So okay. As you can see, this is how we are now finish or root our B tree node. And if you're going to traverse it, 7, 8. So let me just get this color here. This is the traverse. 7, 8, 1, 2. What just happened here? Okay. And then the red node here. So if we were going to, this is how our B tree has a little bit of extra spaces. This explains why you need extra spaces in the array. So let's draw it out real quick. And this is our end result. 11, and then 10, then you have 7, 8, and then you have 20. This is our B tree. I hope you guys enjoy this video. Sorry for the long explanation. This thing was not easy to explain, and I hope you guys enjoy this video. Thank you so much for watching.